In this video, we are going to solve the Leetcode problem of the day, and the problem is zero array transformation part 1. The problem number is 3355 and the problem category is of medium level. But I would say once you watch this video and understand the problem and understand the concepts, this problem will seem very easy to you. In this problem, the given input is an integer array and let's call it as nums. All the numbers in this integer array will be positive integers, or it can be 0 as well. There is also one more input which is a two-dimensional array, and let's call it as queries. And this queries array is a two-dimensional array in which every data is itself an array of two elements, the left index and the right index. Basically, these are the starting and ending indexes which we will make use of when we will try to solve the problem. The output which we need to give in the problem is true or false, basically a boolean true or false. And the output is based upon the task. So let us try to understand the task. In the task, we just need to make the array nums which is given in the input as zero array. What is a zero array? It is the array in which all the elements are 0. So we are trying to make all the elements in the nums array as 0, and if we are able to make all the elements as 0, then we can return true, otherwise we will return false. Now for each of the query which is given in the queries array, for each of the query which is a array in which we have two elements, left index and right index. So for each query, li and ri are the input, and what we need to do is we need to decrement the element of nums at the index I by 1. What is this I? This I is from li to ri, which is given in the input, the queries array. And if you are confused, don't worry, we will see some examples to understand it completely. In the question, it is mentioned that we can select a subset of index from li to ri. But how I would say, how can you read this statement is, you need to just decrement the value of nums at index I by 1, but avoid the decrement if the nums of I is already 0, because our target is to make the elements of nums as 0 at each index. So if it is already 0, you don't need to do the decrement by 1. And that's what the question is saying. You just need to select a subset of indexes from li to ri such that you are able to make the array 0 array by decrementing the value at nums of I by 1. Well, that's all about the question. Let us try to understand it using some examples. So in the example number 1, the given array nums is 1, 0, 1. It has total 3 elements, and there is a queries array which is a two-dimensional array. You can see it is a two-dimensional array in which it has one more array. This array has two elements, 0 and 2. This 0 is li, this 2 is ri. And we just need to decrement the value at nums from index 0 to index 2 at each query. That's what we need to do. But it is not compulsory to decrement the value. We just need to select, do we need to decrement the value or not? And let us try to understand it. If the query is 0, 2, let us say the q1 which is 0 to 2. So the indexes from 0 to 2 are 0, 1 and 2. The numbers at this index is 1, 0, 1. That's in the nums array 1, 0, 1, right? Now, it means that we can decrease the elements at nums at index 0, at index 1, at index 2. And we need to decrease it by 1. Now, if you see the element at nums of 0, it is 1. So it is 1. Our target is to make it 0. So we will do the decrement and this will become 0. At nums of 1, it is already 0. So we don't need to decrement and it will already be 0. At nums of 2, it is 1. So we need to do the decrement and this will be 0, right? And that's what we need to do. We just need to select some indexes from 0 to 2. That's what we have in the queries. And we need to do the decrement at nums of I by 1. And right now what you can see is we have not done the decrement at index 1. So we actually selected the index 0 and index 2 to do the decrement, and we decremented the value at index 0 and index 2 by 1. So our final nums array is 0, 0 and 0. And that's all the queries we had, right? And our final nums is 0, 0, 0, which is a 0 array. So we need to return true. Let us see one more example. Example number 2. The elements are 4, 3, 2, 1 at index 0, 1, 2, 3. And we have total 2 queries here. The first query is 1, 3. The second query is 0, 2. And let us try to process each query one by one. The Q1 is 1, 3. It means we need to go from the index 1 to index 3. So indexes are 1, 2 and 3. Our elements are 4 which is at index 0, 3 is at index 1, 2 is at index 2 and 1 is at index 3. We need to do the decrement at index 1, 2 and 3. The elements are 3, 2, 1. None of them are 0, right? So we actually need to do the decrement at each index which is possible for this query 1, 3. So we will select all the 3 indexes 1, 2 and 3. So the elements are 3, 2 and 1. It will get decreased to 2, 1 and 0. At each index we have decreased the element by 1. So now the array is 4, 2, 1 and 0. This is not a 0 array, right? But we still have one more query which is 0 to 2. Let us try to process it. We have indexes from 0, 1 and 2 because the query 2 is 0 to 2. The elements at index 0, 1 and 2 are 4, 2 and 1. This 0 is at index number 3, but our query is right now 0 to 2. The elements are 4, 2 and 1. All are more than 0. So we need to do the decrement. So this 4 will be 3, 2 will be 1 and 1 will be 0. Now we don't have any more queries left, and this is our final nums array after performing the decrements at the possible indexes. Now this is not the 0 array. We have 3 and 1 which is not 0, right? In 0 array all elements should be 0. So this is not a 0 array and we need to return false. And that's how we need to do. We just need to run over our each queries, do the decrements in our nums array, and at last we need to try to make all the elements in our nums array as 0. If we are able to make it, return true. If we are not able to make it, return false. Now, what is the solution approach for this? First is brute force. That is, we will try to do everything which is possible without any extra logic. For this, what you can do is, you can just run a loop for the queries in the queries array. So basically, we have a queries array, right? For example, this one. We just need to run a loop on this queries array, and we need to process each query one by one. This is the first query, this is the second query. So we need to run a loop for the queries array. We need to process each query one by one, and for each of the query, which is having two elements, L and R. This is the left index, this is the right index. We just need to run a loop from L to R, and let's run a loop using the variable I. So what will happen? We just need to see if the nums of I is more than 0. It means we need to do the decrement because the element is more than 0 and we need to make it 0, right? So we will say nums of I is equal to nums of I minus 1. And after processing each query, for each query we will process from index L to index R, and we will do this particular operation. We will just return sum of nums is equal to 0. So basically what this will do is, this will calculate the sum of your nums array, and if it is a 0 array, then the sum will be 0, right? Then this condition will be true. So this is basically a condition that if sum of nums equal to 0, then we need to return true, and this will be returned as true if it is a 0 array, and if it is not a 0 array, this condition will be false and we will return false. Now this brute force is not the best or not the optimized method. The time complexity for this is going to be O of n multiplied by q, right? Where n is the number of elements in your array and q is the number of queries. Why? Because we are running a loop over our queries and we are processing in each loop from L to R. So this L to R can have a total number of n elements, which is the possibility, right? So the worst case time complexity is going to be n multiplied by q, and this is not the best one. And that's fine, but let us see the solution, how this will look like if we are trying to solve it using brute force. So this is the brute force solution in which we are trying to do everything possible. We are just running a loop in our queries array, and then inside this loop we are running another loop which is from the range of q of 0, which is the starting range, and q of 1 plus 1, which is the ending range. Then we are checking a condition that if nums of I is more than 0, we are decrementing it by 1, and at last we are returning the condition that if sums of nums equal to 0. If this is a 0 array, this will be true. If it is not a 0 array, it will be false. Now this code is actually good for 662 cases, but not for all cases. We have 6 number of cases for which it is telling me it's a time limit exceeded error. Now it is fine. We will try to optimize the process. So let's see what is the optimal process to solve this particular problem. So let us see the optimized approach. In the optimized approach, we are actually going to have a time complexity of O of n plus q instead of n multiplied by q, which is a really good thing. In this approach, let us take an example of this, which is a nums array. It has 5 elements, 3, 2, 2, 1, 0. And let us take this as our queries. This is our queries array in which we have 4 queries, 0 to 2, 1 to 3, 0 to 3, and 2 to 4. Now first of all, what we need to do is we need to create an array which is going to store our power at each index. Now what is this power? The power is how much we can reduce at each element or at each index. See, the thing is, if this is our array, try to think about this. If this is our array, what we need to do? We need to make this 0, make this 0, make this one 0, make this one 0. This is already 0, right? So we need to make 4 of the indexes as 0. Index 0, 1, 2, 3. Now, at each index, how much can be reduced? It's based upon the queries, right? Different queries, for example, 0 to 2 will have different powers at each index, right? For example, if it is 0 to 2, 0, 1, 2, then this query is giving me a power that I can reduce 3, 2, and 2 by 1. Then this query 1, 2, and 3, that is 1 to 3, will have a power to reduce 2, 2, and 1 by 1, right? So these queries are actually giving powers to different indexes to reduce it by 1. So we need to create an array which will store the power at each index based upon the queries. This power, again, it is how much we can reduce at each element. Now let us call it this particular array as pre-ARR. Okay, so we will try to compute the value of this pre-ARR. Let us see how. Now this is the input. This is the nums array 3, 2, 2, 1, 0. These are the queries 0 to 2, 1 to 3, 0 to 3, and 2 to 4. Now let me write these queries in this format. The first query 0 to 2 is 0, 1, 2. The second query 1 to 3 is 1, 2, 3. The third query 0 to 3 is 0, 1, 2, 3. And the fourth query is 2 to 4, which is 2, 3, 4. Our elements have indexes as 0, 1, 2, 3, 4. Now what is this table telling me? This table is telling me that at index 0, I can reduce it by 2. This is telling me that at index 1, I can reduce it by 1, 2, and 3 times. This is telling me that at index 2, I can reduce it by 4. These 4 queries allow me to reduce the index 2 by 4. This is telling me that I can reduce the index 3 by 3, and this is telling me that if required, I can reduce the index 4 by 1. Now how can we calculate this pre-ARR? Before that, let me actually show you one thing. If this is 2, this is 3, this is 4, this is 3, and this is 1. Basically the count of the numbers. 2, 3, 4, 3, 1. If we put it here 2, 3, 4, 3, 1, it means that this can be reduced by 1. It is not required, so we will not do it. This can be reduced by 3. It is 1, so we don't need to reduce it by 3, but we can reduce it by 1. 3 is the power. You can reduce it maximum by 3, but let us reduce it by 1. So this will be 0. This is 2. It means it requires at least 2 power. We have a power of 4 at this index, so we can make this at 0 as well. We can make this as 0 as well because it is 2. So we need the power of 2, but we have a power of 3, so we can definitely make it 0. This is 3. It means that it needs the power of 3. We have total power of 2 at this index, at index 0. So we can reduce it by 2. We will make it 1, but we cannot make it 0. So we actually need to return false for this input. But this is how we can do it. If we just compute the powers, we can compare it at each indexes, and if it is possible to reduce it to 0, then it is good, right? We are good to tell it is true or false. So let us try to create this pre-ARR. What we are going to do is, we are going to process each of the query once. This is pre-ARR, and the elements in pre-ARR will be 0, 0, 0, 0, 0, 0. How many zeros? It will be one more than the number of elements we have in our array, and I will tell you why do we need this one extra 0 or one extra space. When we talk about this 0 to 2, what we are going to do is, at index 0, at the starting index, we are going to put it as 1. Index is 0. So at index 0, pre-ARR will be 1. Now how this is going to help us? If this is 1, after processing all of it, whatever the value of our pre-ARR is, what we are going to do is, if this is 1, let's say, then we are going to say this one will be added here, this one will be added here, then here, then here, and then here, right? But the thing is, if it is 0 to 2, we have the powers at index 0, at index 1, at index 2 to reduce it by 1, 1, and 1, right? But this one is telling me that this one will be transferred here, then here, then here, then at this index, then at this index. It means all the indexes after this one. But we just need it till 2, right? Index number 2. So what we are going to do is, we are going to say, okay, this is the ending index at which we need the power. So 0, 1, and 2 is fine. At index 3, we will say 0 minus 1. Now how this is going to help us is, this 1 will be transferred here, this will be 1. This 1 will be transferred here, this will be 1. This 1 will be transferred here, then this will be 0. This 0 will be transferred here, and then this 0 will be transferred here. So basically what we are doing is, we are setting this as 1 and this as minus 1, so that only from 0 to 2 the effect is there. The addition of 1, the effect is from 0 to 2 only. So from 0 to 2 it will be this one, and then it will be minus 1. This minus 1 is going to negate any addition of 1. And that's all we need to do for each of the query. And you will see how this is going to help us. So for 0 to 2, this will be addition of 1 at index 0, subtraction of 1 at index number 3, which is just after this index. For 1 to 3, it is addition of 1 at index 1, subtraction of 1 at index 4, just after this one, right? So this is the index 4, so minus 1. Now for 0 to 3, addition of 1 at index number 0, the index 0 is already 1, so this will be changed to 2. So I think this should be 1 and this should be minus 1, right? So when we will process 0 to 3, this 0 will be plus 1, so 1 to 2. And then at index 3, after index 3, which is index number 4, so it will be minus 1. So from minus 1, it will be changed to minus 2. And this will be 1, right? Because this one is going to go here, and this will be minus 1. So let me get rid of this. Let me make it right now. So what about this one? When we will try to process 2 to 4, we need to change at index 2. So what is index 2 here? This is index 2. So this will become from 0 to 1. At index 4, the power should be there. So we need to say at index 5, we need to say minus 1. Now that's why we needed this extra index, because we are making a decrement at 1 more than the last index, and this last index given can actually be the last index in our array. So we need one extra element so that there is no index out of bound or index error, right? So at this particular index, we are going to say minus 1. So this will be minus 1. And these elements are 2, 1, minus 1, minus 2. Now this is the power we have. This power is going to tell me how much we can reduce at each index. Okay, so let me write it here. 2, 1, 1, minus 1, minus 2, and minus 1. These are the powers we have at each index. What we are going to do is, we are going to say 2 will be here, then 2 plus 1, this will be 3, 3 plus 1, this will be 4, 4 minus 1, this will be 3, 3 minus 2, this will be 1, 1 minus 1, this will be 0. Now we don't need this one because this is an extra index. We just need to deal with this one. These are the powers we have at each index. We can reduce at index 0 the element by 2, at index 1 the element by 3, and index 2 we can reduce the element by 4, at index 3 we can reduce the element by 3, at index 4 we can reduce the element by 1. And these are the elements we have, right? 3, 2, 2, 1, 0. Now we are not actually going to compute this array. What we are going to say is, we are going to say if this is the power we have at this index, at index number 0, but the power we actually need is 3, right? At least it should be 3. So at index 0 only we got to know that we cannot make the index 0 as 0. So we are going to say return false, right? That is, we need to check for each index. Can we make it 0 using these powers? And if we can make it 0, we are going to say true, right? But right now we can see that at index number 0, the element is 2. That's the power we have. The number is 3. That's the minimum power it needs to be reduced to 0. So we need to return false. But just to explain you how this will be true, let us say that this is the power at index number 0. The power is 3. Let us say the power is 3. Rest of them are same. 1, 1, minus 1, minus 2, and minus 1. That's the same. Now how can you check, are these powers sufficient for this input? We are going to check it index by index. At index 0, the power is 3. The required power is 3. So it is fine. Now at index 1, we are going to add this power 3 plus 1. And that's what we are computing over here, right? So the moment we will check it, that's the moment we will add it. So 3 plus 1, the power is 4. We need the power of at least 2, which we have, right? So this is fine. 4 plus 1 is 5. The power is 5. We need 2. This is fine. 5 plus minus 1 is 4. Then this is the 4 we have. At this index, we need just 1. So this is fine. 4 minus 2 is 2. We have a power of 2 at index 4. It's already 0. So this is already fine, right? So we can make all the elements 0 of this array nums. So we can return true if this would have been 3, right? Just compute the powers we have, and then we can check at each index, and then we can return true or false, right? Now the thing is, let's say this would have been 10. So how this would have affected? See, the thing is, 3 is the power we have. 3 is what we need. It's fine. Here the power will be 4. 3 plus 1. We need 2, which is fine. 4 plus 1 is 5. The power we need is 2. it is fine. 5 plus minus 1 is 4. The power we need is 1. It is fine. Now 4 minus 2 is 2. The power we need is 10 because the value is 10. So we need to reduce this element by 10, right? That is, there should be 10 different queries which are able to reduce this element by 1. But we just have 2 queries, right? So we need to return false. And that's all we need to do, guys. So let me actually get back to the code editor and let me show you how the code will look in Python. And this is going to make everything clear. So this is the complete code we have using Python in the optimized approach. And this is actually O of n plus q time complexity. First of all, what we are going to do is we are going to create this array. This is our power array. It should have 0 at each index, and number of elements it should have is length of nums plus 1. That plus 1 we already know why we need it. Now you can run a loop in the queries array, and you will say for the starting query we will say plus 1, and for ending query plus 1 index we will say minus 1. So this is what we are going to do to create our power array, and then we can create a variable called as current power, which is 0 for now. This print you can actually ignore. Then run a loop in our nums array for I in the range of length of nums, and you can say my current power is equal to current power, which is 0, plus what's the power we have at index 0. So it's going to update our power at each index. Then we are going to check if nums at I is more than current. This means that it needs more power than we already have, so we need to return false. So this is the condition we need to check for each index, and if we are able to come out of the loop without returning false, it means that we have sufficient power at each index and we can convert each element at each index as 0. So it will be a 0 array and we can return true. And that's the complete solution for this particular problem. You can just submit the code and you will find that this is actually a pretty efficient code for this particular problem. So yes, you can see it is a pretty efficient code. The runtime is good, the memory used is good. So yes, we have solved this problem, guys. So that's it for this video, guys. If you liked the explanation of this video, if you understood the problem, understood the solution approach as well, then make sure that you hit that like button. And if you're not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.